Good afternoon. Am I audible to you guys? Am I
Yes,
audible?
ma'am.
Am I audible? Okay, so today we will see program to implement Q. Okay, before going to the program, let's see the logic first. So what happens in Q? As you guys already know, this is a derived data type. That means stack or queue or anything you can implement it with the help of any other data structure. For example, array, or you can also use other data structures like linked lists. So today we will see just the program to implement queue using your array. Okay. So what happens here? Normally for queue, okay. So for example, this is the size of your array. So I will directly go to the logic part. Okay. Write a program, maybe you can just define any size for the array. You can also use define function for the here I use 5 to just 5. After that you can take anything. You take your queue with n. So whatever value you define in the define right, that will be the size of your queue. Okay. So what's the main logic? What we do? We always initialize front and rear to be -1 and -1, right? That means your stack is, sorry, queue is empty. So for this, you can take variables like just take front equal to -1 and rear equal to -1. So the main operations for queue is enqueue, dequeue. Okay, these are the main operations we are going to implement. Then after that, we will have a display function just to show the numbers stored in your queue. So what we do, initially, we just set it to be -1. That is correct. Then you can just use a function name and queue. You can just keep anything. Okay. So here we are going to take one value. I'm going to add one item, right? So in it will be one item. So under here, what we do before adding an item, we always check the overflow condition, right? Overflow is whether this queue is already full or not. If full, we will show the overflow. Otherwise, we will simply add the item. So what is the first condition? Remember in theory class also, I said if this is the front and this is the rear, and rear should be, suppose there is something here, just for example, something is here. So you can say rear equal to n minus 1 and n is total 5 minus 1 equal to 4. So you can just say if r equal to n minus 1, that means that is a overflow condition. So typically you can write here that if rear equal to n minus 1, then you can simply print overflowing. Okay. Next, what should be the other condition? When will you add item? I've initialized both to be -1. That means if I want to add an item, so I will set to F0 and R0 1. So both front and rear will be initialized to be the 0. Okay, and then you add the item. For example, something is here. So you can write the same condition. Else if 1 equals to -1 and rear equal to -1, that means your queue is empty. That means what you will do first, front and rear, you will set to be the 0. Then you can simply add the item. Where will you add the item? Where will you add? Will add at the rear side. Therefore, we'll simply write equal to x. X is the item we are going to add. So if front equal to -1 and rear equal to -1, you will set both front and rear to be the 0 and insert the item here. That means you have added the first item. Okay. So this condition is satisfied. Now we have another condition. See, here, the item is already there. We always add from the cell, right? So now your queue is not empty. Okay, queue is not empty. So what's the condition for that? What's the condition for that? Now your front is not equal to -1 and rear is also not equal to -1. This condition is for when queue is empty. Okay, now you have to also put the condition when queue is not empty and you want to add something. What you will do for that? You will do front and rear both are here. And your this is not empty. What should be the condition? Else, it's simple. You will just increase the rear. You always increase the rear pointer by 1. Then you will simply add the item to the rear side. That's it. That's it for your NQ operation. So before adding any item, what you will do, you will check the overflow condition. Else, you will check whether queue is empty or not. If queue is empty, then you will write this condition. If both are -1, that means queue is empty, and you will increase the pointers, then you will add the item. Now, if queue is not empty or something is already inside, if some values are already there in the queue and you want to add, what you will do? You will simply increase the counter of rear and will add the item. Right. So if you want to add the item, what you will do? You will increase the pointer by 1, then we'll add the item. Next, you want to again increase the rear pointer and you will add something and so on. Okay, got the operation? Yes, no? If any confusion, just ask. Is it clear? The NQ operation. What are these conditions? Why we are checking it? Yes, no, anything you want me to repeat, repeat once. Okay. So to add any item in a queue, what you will do first? You will first check the overflow condition. Right? If stack queue is not overflowing, means if your queue is not full, then only you can add. Like just like stack, we always check the overflow condition before adding the item. So what will be the overflow condition? When say initially rear point is here. So if rear point is at the last location, that means what? Your queue is full. Okay, if your rear pointer is here, that means your queue is full. Therefore, you will print simply the overflow condition. If rear equal to n minus 1. What's the n here? 5. 5 minus 1 is 4. That means if your R is at the last location, that means it's full. Your queue is full. You cannot add any more items to the queue. Therefore, it will write overflow condition. Okay. This is one condition. Next, you have to check whether the queue is empty or not. Okay, that means you want to add something to a empty queue. So what's the condition to check if queue is empty? Front equal to -1 and rear equal to -1. Okay, we have initialized it to be the -1 and -1. If both are -1, that means what? Queue is empty, there is nothing inside the queue. So you will set the value of front and rear to be 0. Okay, that means it was -1 -1, then you will set it to be 0 now. Front equal to 0 and rear equal to 0. And after that, you will simply add the item. You can add item in the first row. You are adding from here. Don't get confused. I'm not adding it from here. Rear side is this side. Okay, I'm adding from this side only. This is the front part. Okay, this is the front part. Don't get confused. I'm adding from here. 4 will be placed in the first location. Okay, initially front and rear -1, that means it's empty. So the moment you want to add something, you will check whether it is empty or not. If it is empty, then you will set the value F and R to be 0. After that, you will enter it. Okay, so this condition will satisfy when Q is empty. Now, see here, there is already item inside the queue. So, is it satisfying this condition? The 4 is already inside the queue. That means this condition is not satisfying now. Now, queue is not empty. Queue is empty when front equal to -1 and rear equal to -1. But now there is already an item inside your queue is not full. Then it works. We'll simply increment the counter. I will be here and you will add the item. Right? So same thing. If some values are already there, you will simply increase the rear pointer and you will add the value here. Here means you are adding from the rear end. X is the item you are going to add. That's it. So first check overflow condition. Then if you want to add to a empty queue, will write this condition, or if there is already some values, then you will simply increment the counter and place the value. Okay. Is it clear now? So every time you want to add something here, you will increment the counter and you will add something. And finally, your R value will be, means rear pointer will come to last. That means your queue is full now. Rear pointer is here. It will always travel from left to right. Initially it was 0. Now R is at, which is n minus 1. Now, if you want to add anything, it will be overflow condition. It will not add, or it will simply print overflow. Okay, that's anything. Now, what will be DQ? You can also make it int main. Okay, it's fine. If you make it int main, then you just need to return 0 here. Return 0. Okay, in function, when you use in function, just return 0. In void function, you don't need to return an integer. I hope you guys remember that one. Okay, now what is the DQ? We have to make another function. Let's stick for now. DQ. Okay, that means you have to delete item from the queue. So void DQ, this you want to add something. Sorry, delete something. So what's the first condition to check before deleting something? Before deleting any item from queue or stack, which is underflow condition. Underflow means whether queue is empty or not. So what's the condition to check whether queue is empty or not? This one, correct? So you just check if front equal to -1 and rear equal to -1. Okay, if yes, that means what? Your queue is empty. So you can simply print underflow. Correct? If it is not underflow condition, that means something is there. What you will do? Suppose there is only one item. Okay, and I'll come to this point. For example, in your queue, there is only one item. Only one item is there. Now what? Your x equal to 0 and r is equal to 0 at this point. Correct? We have just added one item. And now you want to delete that. So what you will do means only one item inside your queue. We have to write that condition. Else if front equal to rear, that means there is only one item. What you will do? You will simply decrement the counter value. Front and rear you set to be the -1. Okay. If there is only one item in the queue, we'll simply decrement the counter, set the counter -1. Okay. When you will have front equal to rear, only when there is only one item. That means it's supposed to be in the first position. So you will simply decrement the value to be the -1. Okay. Now suppose your queue is not empty. There are some more elements. Suppose now this condition is not just fitting with this now. Front is not equal to rear, but there are something else, right? It is in different location. So what you will do, you delete the item, you will simply do front minus plus. Okay, front plus plus, sorry. Front plus plus means when you want to delete the item, front will come here, front equal to 1. Okay, next you want to delete one more item, you will again increment the value to be here, front equal to 2. Correct? So that's it. If you want to delete any item, you will increment the front pointer. Now if you want to show what is the item you have deleted, you can simply print the value. Okay, simply print the value. That's it. That's all for DQ. Clear? Good. For deleting item 1, we first check the underflow condition. Underflow means your queue is empty. We already know how to check queue is empty, whether front equal to -1 and rear equal to -1. If yes, it's underflow condition. You cannot delete anything. Next, you will have to make a provision if in the queue there is just only one item. If so, then you will simply decrement the value to be -1, -1. Okay. Next, other condition is it is not simply the first. There are different more than one item. So for more than one item, what we do, we will simply implement the front count and it will be deleted. Okay. And if you want to print the value, you can just write like this. That's it. Okay, so what will be the complexity for these two operations? What will be the complexity? For NQ, what is the complexity? And for DQ, what will be the complexity? What will be the value? Tell me. Tell me the time complexity for both. Or just use the logic. It's very simple. What will be the complexity? O1 for both. Yes, correct. For both, it is just constant O1. Why? Because you are simply adding an item one at a time. You are also deleting an item one at a time. So for both, just like stack, it's just O1. And if you want to source something, then what will be the complexity? Search, or you can also say display. What will be the complexity then? You are searching a value in a queue. Just think about the stack. O and yes, correct. You have to go through all the elements. This is O and clear both and Q DQ. So let's see the program. Can you see this screen? Can you see the program also? Is it yes?
No, ma'am.
So what's happening in the program? It just say the inside n I'm just written max size for the queue is 5. Then I have initialized two three operations insert delete DQ display. You can keep any name here. Okay. So first I have initialized front and rear to be the -1. Then initialize the queue with the size x size. Then our main program has started. So here also it's just the same, just like that. A menu is given to the user to select whether the user wants to insert an item, delete an item, display an item, or what. Okay, so for choice, here we have given 4 choices. Therefore, choice not equal to 4. The loop will run until we have selected the 4 things. Okay, then it will keep repeating. In choice, again, we have for case 1, means if you want to insert the item, it's calling the function insert. For case 2, it's calling the function delete. For case 3, means display the queue, it's calling the function display. And for case 4 exit, it will simply exit. And default value is enter the value choice. Okay. Now our enqueue function will start. So here is the same. First, just enter the item and checking whether rear equal to max size -1. If yes, it's an overflow condition. Then it is checking whether it is empty or not. Front equal to -1 and rear equal to -1. Then just set the value front equal to 0 and rear equal to 0. Then here, otherwise rear equal to rear plus 1. That means rear plus plus. So next, you just enter item onto the rear and value inserted. Next, for the delete, we are checking the underflow condition. So checking whether front equal to -1 and front greater than rear. Okay, front greater than rear. Sometimes what happens is that the front is before the rear. Okay, so in that case also, it's the underflow condition. Front equal to -1 means 1. That means it's empty. Front equal to -1. That means it's empty and it's an underflow condition. Here instead of rear equal to -1, because if front equal to -1, we don't care about the rear actually. So here just checking whether front is greater than rear or not. Okay. Okay, it will come to this part, front greater than rear. Suppose at one point, front is here. Okay, and rear is somewhere here. Okay, and then in circular cube, or suppose rear equal to -1. Okay, and your front equal to 0. Okay, so now here front is equal to greater than 0. Okay, this front greater than rear is actually also applicable to the circular cube. Okay, same thing we can keep here as well. When we'll see the program for circular cube, or we will learn more about circular cube, we will learn this. Sometimes front can be before the rear. So then also it will be a underflow condition. Okay, next. Otherwise, what you will do, you will simply put the item in the front, then check whether front equal to rear or not. If yes, then you will set the value front equal to 1 and rear equal to 1. That means if there is only one item at the queue, then you will simply delete the item. Okay, otherwise you will just do front plus plus. Okay. Next, for the display, you are checking whether queue is empty or not. So queue is empty, just checking one value, rear equal to -1. Okay. Otherwise, it will simply print the values from front to rear. Okay, if we run this program, enter choice, like one more item. Okay, now I have inserted 3 items. So let's see what are the values. 4, 6, 8. So if you notice, 4 is the first item I entered. Okay, 4 is the first item. Then I entered 6, then I entered 8. So this is in order 4, 6, 8. Now if I delete one item, I want to display what value I have deleted. So it's the 4. So first item was 4, and when I deleted one thing, the 4 will be the deleted. So first in, first out. Okay. Next, you want to delete one more item and display. Now 6 will be 4. Okay, now 6 is gone because 6 is the second. Next, it's going to delete one more item. Now it should be okay. It's showing empty because we have deleted all the items. It will show under. Okay, because there is nothing inside here. Okay, then there can be many different programs. You can select any one. Just that the conditions supposed to be in order. We have to make provision for all these conditions. First, overflow. Then, whether it is just a single element or there is more than one element in it. Same for delete. You check the underflow first, then check whether there is only one item inside here or if maybe there is more than one item inside that. Okay, got it? Is it clear? The program here, just the same what we discussed here. You can write in anything. Just one type of filter. You can use others also. You can write your own also. As per your convenience, it's fine. So is it clear, everyone? Okay. Then I have another program as well. Just save. Here also just save. Okay, just read it. Display the item. So it's just showing 378. Okay. First item, I entered is 3. Last item, 8. Okay, delete the item. Display the item, 3 is gone. Okay. So if we check, okay, this is almost similar to the same one. Checking the underflow condition here. For checking whether it is empty or not, it's just going with 1. Okay, if front equal to -1, you just set the value front equal to 0. Okay, rest is just the same. And for D2 also the same underflow condition, and it is deleting the item. Okay, but plus 1. That's it. Okay, you can use any of this program. Okay. Stop share. Take it. So for all, is it clear? The NQ, DQ operation, okay. New students might get it a bit difficult. So, Agiasa, you can provide the class links or the YouTube link for CSE. and the new students can follow up all the previous classes. Okay. And if you guys don't understand anything, the new students, you can ask. If needed, I can take extra classes for you guys. Okay. Okay, thank you all. Winding the meeting. And I'll share the program with you guys.